Hey guys, and welcome to a live stream going over the Analog Discovery 2 bundle and doing an unboxing of what you actually get in the bundle. So I thought this would be an interesting thing. I just got a second version, so I already had an Analog Discovery 2. I've been using it. You've seen past streams. I've been enjoying it. It's been, it's a great little tool. It's great for the road. It's great for, it's great for your bench, especially if you're getting started. And so I wanted to show what it is and what you get, and then just remind people what's going on here. So let's start with that. If we go here, there was an announcement a couple weeks ago, or a couple weeks. Geez, has it been weeks now? Anyways, but basically, if you buy 3 months of Contextual electronics up front, you get access to the academic pricing. So basically, for the same price as the bundle itself, you also get Contextual electronics thrown in, which I'm very excited about. So it's a really good deal, I think, and like I said, the tool itself is great. So there's more info here if you go to contextualelectronics.com/blog. If you have any questions about it at any time, you can go over to the forum and ask some questions over here. You can ask about what's going on, and if you've got any other stuff that you want to ask about on contextual electronics or just on generally on electronics. So let's take a look over at the bench. I've got the box, and hopefully my address isn't on it, but if it is, who cares? All right, so here it is. This is what showed up. This showed up in a FedEx box, actually, and so this showed up earlier today. And there's not too much stuff in here, but still good to know about. So the first, well, let's go straight to the main event, I suppose. So this is the Analog Discovery 2. So it does come in this nice box. Now, what I ended up doing is, well, I'll show you as I get down into this, I suppose. Let's see, how do I get this off of here? Have to rip it? No. Maybe here. Yeah. And I'm going to rip it. So as you see on here, it is, and I'm pretty sure that this is what the academic pricing comes from, basically them getting some donated parts and stuff from ADI and Xilinx, and that's what is internally in there. It shows on the back the waveforms. That is the software you need to have installed, and there was a recent update to that as well. Taking a look in here, so this is the thing that I really like. This is the big difference between the Analog Discovery 1 and Analog Discovery 2. So this is the nice case here. This thing is pretty much, it's pretty rock solid. It is a nice piece of injection molded plastic. Inside the actual container here, you get, pretty standard. You get a micro USB cable, and then this is really the main thing here. Is this 24 pin, I think, but basically this plugs. Looks like 24 pins or so. Yeah, you get 16 digital on the right. You've got T1 and T2, which is the trigger. The down arrow, which is ground. W1, W2, that's waveform 1 and 2. V plus, V minus is the positive and negative supply. Another set of ground, and then 2 plus, 2 minus, 1 plus, 1 minus. Those are the scopes. There's 2 channels of oscilloscopes on there. So, and like I said, sorry, this is keyed, so that's nice as well. You just plug that right into there, and you're good to go. Nice little ponytail. Looks like there's also just some ferrite beads, or ferrites for the cabling here, and then some headers. And so what I did, and what I usually tell other people to do as well, is I just take this whole thing out of here. Oh, this is nice, actually, having a reference document like this. But then this actually is a great little carrying case, and really I got all my stuff in there, and I'll show you, basically stacked all together. But between this and the other stuff we have, it's a nice little carrying case for the whole thing. So I'll just put all this stuff back together, I suppose. Usually have to take stuff apart, but whatever, just a little bit less together as you're doing it. And I'm going to take a quick second to see if anyone's actually here. If you've got any questions, looks like there are some people in the watching this. So if you have any questions, you can ask in the chat. I know it's kind of late here, so I'm starting to kind of fade. But yeah, if you have any questions, you can ask in the chat. I'll try and catch those before I head out of here. Okay, and so like I said, this is in here. So let's put this stuff off to the side. Oh man, my lab is really hot today. All right, let's put that back here. Now, this is the other thing that I want to show. So this also is part of the bundle, and what this is the the BNC breakout board, right? And so this is useful because, like I said, there's two scope channels. There's a plus minus channel for plus and minus input for channel 1 and channel 2, right? And so that gets broken out here. So this one's channel 2, this one's channel 1. You can see as well that there's a switch here for AC or DC coupling. Now, if you're used to traditional scopes, usually it's like a digital selection, but really what most of the time they're doing is they're switching in an RC network. And if you can see it in there, let's see, maybe I can go to the, let's see, is this any better? So if you can see it in there, it's not much better. Mechanical focus. Focus. There it is. Nope. Yeah. So there you go. R3 and C1 on the channel 1 there. That is getting basically jumpered in with that AC-DC switch. So that's really nice there. And then up on top here, there's a, well, it's a little harder to see, I suppose, because of the lighting. But then this is a 0 or 50 ohm matched output. These are the waveform outputs. You see W1 and then W2. Trying to make sure I don't undo my focus here. But and there you can kind of see it, 50 and then 0. So it is set to 50 ohms right now. And that's just impedance on the actual output here. So that's nice. So what I was going to say, though, is that this whole thing plugs together now, right? And it's kind of hard to, it's actually, it was a little confusing at first, but if you see channel 1, channel 2, right, on the left side here, but then if you look underneath here, and this is kind of the key point, is that they actually do not pass that through, right? So all of this stuff, you can kind of see the ground traces, or sorry, the ground planes underneath. Yeah, you can kind of see it with the light. And you see that it's just going over to channel 1 and channel 2 here. So, and then it does not go down to the bottom header. But the nice thing is that when you want those digital signals, now it's not keyed now, but you can go and then plug this in. You still get all the digital signals. What you won't get is you won't get the channel 1, channel 2 on this square pin female header, I suppose, or female wires out here. So that's good to know. Okay, so that is this piece here. Let's switch back up to the arm. And I will also double check my questions if there are any. No questions, that's fine. Cool. And so the last piece is the scope probe. So this is another part of the CE bundle. In here, pretty standard. I mean, these are not particularly fancy. Obviously, the matching on these things. So these can do up to 100 megahertz, which this scope can do about 20 to 30 megahertz analog bandwidth, which is fine, really, for what we're doing. But what you see is 60 volt DC max, and then these are X1 probes here. So these are X1 on the on this matching part here. You can go and you can use the so this black thing is actually a tiny screwdriver, which you can add in. You can get into here, and then with if you have the screwdriver, there's a small capacitor in here. You turn the trim pot, and it changes the RC constant so that your square waves will look more square. Basically, the matching that happens into here. But then over here on the probes, right? These are pretty standard, whatever. Little witch's hat, right? So you can little grabber that comes out of there, right? And then you can also switch between 1x and 10x, and then you can ground reference things as you want as well. Okay, and so these plug right into here, right? Now, if you're wondering, like, well, this seems like a little bit exposed, right? It's not. It's definitely not. Like, this is not going to do super high frequency signals for you, right? I mean, this is obviously, it is an exposed PCB. These are probably not super. I don't really know anything about the matching on the layout, but this is not meant for like super high frequency anything, right? For that kind of thing, you go and get a full-fledged scope. What this is a great value because internally it's got a logic analyzer, it's got a protocol analyzer for the 16 digital channels, it's got 2 scope channels up to 20, 30 megahertz or so. It's got 2 waveform generators, I think 10 megahertz or so. I don't even know the exact specs. I should probably know that. But then programmable supply, it's only plus or minus 5 volts on the output here. But then, so then that goes out to here. And so basically, if you're working with, if you've got a breadboard and basically right from the start, you can start plugging into a breadboard and interacting with components. If you've got, through-hole components, you can do that kind of thing. Really, really, really like this tool. Is there anything else I missed here? Oh, I guess I didn't mention the triggers as well. You can do, external triggering and stuff like that. But, if you are an amp hour listener, which maybe you are if you know about contextual electronics, but I just talked to Akiba a couple days ago. We were also talking about this thing as a test stand, a piece of gear for test stand. So that might be interesting as well. I'm exploring some of that stuff. And I'm just really excited because this is actually what we've been using in contextual electronics for, there's some skills-based stuff, how to use this, but then also we're using it more broadly in the actual coursework. So as we're doing more design and especially more troubleshooting, that's kind of the main thing there, is we need a tool that we can reliably find a tool that is low cost enough for people to get started with, and then it's easy enough and flexible enough that they can do lots of things with it. Let's see. So, people are in the chat now. Hello. Pietra. The square wire thing seems to call fly wires. They're called fly wires. Okay, that's interesting. Yeah, I always just call them like connector wires or whatever. And then Murata says, great kit. I already have the AD2. I found it useful even at work. I actually have a friend who was telling me about they have a full lab setup, right? So really fancy scopes, whatever. But then this kind of thing is great for the desk as well. Also a question about SIGROC. I have no idea about SIGROC. SIGROC is an open source, what is it, logic analyzer, I believe, or something like that. But I am not a SIGROC user, so that is something to look into. So, thanks for showing up. Thanks for watching. This is obviously just a simple unboxing. There's nothing really fancy here. And I'll be doing more stuff both on the, these open videos like this and in, obviously in contextual electronics, the paid videos. If you're interested, there's, like I said, there's a deal right now. If you do 3 months of sign up, you get access to the academic pricing. So at the apprentice level, it's $300 for those 3 months plus the gear, and if it's at the journeyman level, it's $385 for the gear plus the courseware stuff. So I think it's a good deal, and I think I hope you check it out. If you're not, it seems like all the people in the chat are already they're experienced, so maybe people watching this later. So that's all for now. I'm going to get out of my hot lab here and go enjoy the Chicago summers. Hope you are enjoying your summer, and we'll talk soon. Thanks for watching.